Hello everyone. Today we are going to showcase you Anritsu's latest instrument Vector Star. This is from 70 kilohertz to 70 gigahertz instrument, where today we will be showcasing some of the important applications like time domain measurements for the high speed devices and also for the any DUT which has requirement of a time domain. So we have a DUT here where we have a transmission line. This is a transmission line which goes up to 70 gigahertz, from 70 kilohertz to 70 gigahertz. So we will be showcasing you the properties of this, how it looks like. So if you go to the instrument, you can see we can directly see a transmission line S12. So it's a very fair signal. Using the markers we can know different levels at this particular frequency. As we are doing the measurements from 2.8 megahertz to 70 gigahertz, which is a harmonic frequency for the 25,000 data points. We can have either 25,000 data points or multiple channels, or 1 million data points for one channel. So today we will be taking 2.8 megahertz to 70 gigahertz harmonic frequencies, so that we will be able to take care near to the DC measurements. So what is the important thing which we generally see in this particular instrument is using this transmission line, how good the data will go. So to show that, we have an option for the eye diagram. So directly using the eye diagram we can show that how good the signal can go. So using this eye diagram we will be able to generate different types of signals. So here you can see that we can generate an RZ or a PAM4, or we can generate different bit stream like PRBS, K28.5 or user defined patterns, any of these patterns. We can generate different data rate like 32 gigabit per second with the rise time and fall time. We can add or simulate different types of jitters, random jitter, sinusoidal jitter 1, sinusoidal jitter 2, or the noise AWGN with a different frequency offset. So presently we are using a 32 gigabit, and you can see that the results are quite good. The same way we can see that this transmission line is able to transmit a 32 gigabit signal, but once I generate more of this noise to this signal, some noise is being added, so you will see that there will be change, because we are having a 25,000 data point. With the 4th or 8th sweep it will change the structure of this measurement. So you can now see that we are able to see with the addition of this jitter and noise how the performance is. So this is one of the application. Another application which we want to show is we are having again a trace where we have different impedance. We have impedance of 50 ohms. After that we have added a 25 ohms impedance. Then we have added a 50 ohms. So we have a two different impedance, 50 ohms and 25 ohms. So if you want to see this in a time domain, we can see like here we have connected the third port. In the S33 we can see that there is a transition here which is somewhere here because of the signal, and then we have a path. This path is the 50 ohm path. After that there is a sudden dip like 25 ohms path. The signal has gone down to the 25, and then again it will go back to 50 ohms. So this is how a time domain we can see. And to see that this signal, whatever we are seeing, the flatness is not so good, but flatness will be good if we use the measurements from 70 kilohertz till 70 gigahertz. So more the broadband signals near to the DC, we will have more accuracy in the measurements. So this is how a VNA can be used for the time domain and can be used for the high speed device measurement. That's all. Thank you.